Okay, we're going to do an example problem dealing with specific heat and heat energy. So this question asks us how much heat is required to raise the temperature of 4.66 grams of wood from 2.9 degrees Celsius to 76.8 degrees Celsius. So the first thing we need to understand or keep straight in our heads is our different variables. We have C, which is specific heat, and Q, which is heat energy. It's important for us to keep those things straight because they're very easy to confuse. So when we're talking about specific heat, we're talking about joules per gram degrees Celsius. Typically, it could also be calories per gram degrees Celsius or food calories per gram degrees Celsius. But we're going to use joules per gram degrees Celsius because that's what our reference is going to be in. And then Q, which is heat energy, can be joules, calories, or food calories. All right, so this is asking us for heat. So in this case, we're solving for Q. So we are going to use our equation Q equals mc delta T. So now I'll make my variable chart. Q, mc, and delta T. All right, so we begin with M. That is grams. So 4.66 grams is the mass of my wood. And then it goes from 20.9 degrees Celsius to 76.8 degrees Celsius. Again, delta, that means change. So delta T means change in temperature. So if I find the difference between those two, it is 55.9 degrees Celsius. Oops, forgot my label there. That's 4.66 grams. All right, and then I have C here. Of course, this question is asking me for heat energy, so that means Q is my unknown. C is specific heat. So this material I'm working with is wood, and I'd have to go to my reference. So you go to your reference section and find the specific heat of wood. In reality, wood was going to have a range of specific heats depending on its species and all those types of things. But we're going to use 2.5 joules per gram degree Celsius. Now all I have to do is take those values and plug them into my equation. So Q equals mass, which is 4.66, specific heat, which was 2.5, so 4.66 times 2.5 times delta T, which was 55.9. Multiply all those together, and we get 651.235. And this is heat energy. So again, if I look back over here, grams cancel with grams, degrees Celsius cancel with degrees Celsius. I'm left in joules. So 651.235 joules is the amount of energy to raise the temperature of our wood from 20.9 degrees to 76.8 degrees.